a David Bowie Labyrinth Lunchbox. Perfect. So yeah, there's the NAS just kind of hanging out there, and we can connect to it. We can just mount it up with a regular mount command. And it will tell you activity that happens. So it just plays a random sample, and you know, if we unmount,
all users have disconnected from NAS.
Ground control to Major Tom. You've really made the grade.
Alright, so we got our box running over here. So I wired up a little control panel that we can use. So we can do different things on here. For example, if you just want a quick time check,
the time is 3:05 p.m.
you can just hit that. You can turn on or off the hourly chime. You can disable all sounds, so now these things won't have any effect. So that's a software mute. There's also the mute button on the side if you want. And you can just ask for a random song. You know, just play a snippet if you need a little quick Bowie fix. There's also a volume slider, so you can go down pretty soft. And the loudest is pretty loud.
The time is 3:06 p.m.
And finally, there's a shutdown option that will bring down the Pi inside the lunchbox.
System going down immediately after one final song.
And there you have it. That's the basic core functionality. So, alright. So here's the basic setup. There's the Raspberry Pi. There's the external drive. Tons of space inside. So what do? Well, you go ahead and you put a speaker in, right? And you can hook the speaker up to the Pi, and you can have it do various things like, you know, tell you what the network status is, or announce the time, and so on and so forth. Basically just going crazy with the Dremel. Put this all together. It has the speaker port out here in the front, and a pair of switches on the side. That's the main power switch over here. This is the quick kill for the sound, so that'll totally cut off the speaker in case, you know, it's late at night or something like that. Power cord goes in the bottom, and this is the exhaust port for the fan to the Pi. And then everything else is just self-contained, so that can just kind of hang out on the bookcase or whatever. So there's the basic box. This is a side view, so it's covered with cool art from the movie Labyrinth, so that's awesome. If you look inside, it's just kind of, you know, generic case, good for putting in your lunches, extra good for packing in components. So since we got all the space, right, I decided to go ahead and put in a bit of a sound system so that I could have it speak announcements to you and play some music for you and things like that. So first thing was to put in a speaker. Well, Raspberry Pi will drive a headphone, but it won't drive a speaker, you know, that you can actually hear outside very well. So I wanted a powered speaker. So I went to Amazon and I found this thing. It's a pretty small, really inexpensive. I think it was like $10. Powered speaker, plugs into USB for power and a little audio jack, and it's small, you know, it's about 3.5 inches tall, and I thought that would be good, so I was going to put that into the case, but I decided, you know, maybe if I open this up, maybe I can pull out the circuit board and make it just a little smaller. So I pulled the feet off. The screws are always hidden under the feet on these things, and took the bottom off and removed the speaker itself, and what I found inside was a bunch of nothing. Right? There was one LED that flashes blue when your music plays, and that's it. The whole thing was empty. So it turns out that the actual guts is inside this this little volume control on the power cord. Right? That's the speaker, and there's nothing else. So I didn't need that whole box. I didn't need any of the other stuff. I could get away with just using the speaker and that little fob. So that was my speaker setup. All right, next I needed to put a hole in the side of the lunchbox for the speaker to go through, sound port. So I'm in an apartment. I don't have access to a lot of tools, but I do have a drill and I have a Dremel, and these are your best friends, especially in a small space. So I made myself a little template, right? Cut out a piece of cardboard, put it over there, because I decided I was going to use these 4 holes in the speaker to mount the speaker to the inside of the box. So put a piece of cardboard over there, cut it to shape, punched through where the holes were so that I would have a nice bezel to work with. And then I could use that to figure out where I wanted the hole to be in the case. Now, I'm a software person. I'm not very good with hardware. My friends run away when they see me with a power drill in my hands, right? But I decided to take a shot at it anyway. So put that in there, used a Sharpie, marked off approximately where the circle was that I wanted, and then I just went to town and started drilling. So popped through some holes, and didn't worry about the paint job in the area that I was going to cut out, but put in some small pilot holes and put in bigger holes, and just kind of tried to roughly outline the area where I wanted to punch out. And on the inside it looked like this, right? So that's what I had to work with. So now I needed to get in there and start doing some more precise work. So I decided to take out the handle, right? So the handle's just held in with these little tabs. So flip those tabs up and you can pull the handle off. Now I have clean access to the outside without having to work through, the handle hanging over. And basically just kept drilling, and then used a Dremel, a little cutting wheel, and cut an approximate square out, right? And I had a perfectly drawn circle there, showing what the bezel should look like, the whole opening, and then I just started whittling away with the Dremel tool. This is like really fun. This is like, sculpting butter with a warm knife. It's really fun, especially for someone who, as my friend said, spends their life moving electrons instead of atoms. So worked through that, and eventually got a hole cut that was pretty close to the intended size, and then I started doing the fine work. Okay, I also decided I was going to put in a bezel, and you can see there's this little plastic ring there. So to do that, right, you go to Tinkercad and put down a cylinder and a slightly smaller hole inside, and then some parabolas with a negative space parabola, slightly smaller. And the goal was to make a bezel-shaped thing that could cover up that hole so that any minor imperfections or sharp edges in the hole wouldn't be an issue. So shrink these things down, put them together, do the same with the cylinder, put it all together, and then join it and group it, and you've got this nice little bezel-shaped object, right? So this will go inside the hole. You have this smooth edge on the top that'll fall flush with the face, and then you've got something to protect outside from the sharp edges. So that's what this ring is over here, right? That's the printed version of that. And you can see the piece of metal that I kind of punched out by drilling enough holes over here. So that actually worked pretty well. And then you put the bezel in place, and there you go. I tried to super glue this. Super glue did not seem to work very well. I don't think it's the right surface contact, so I ended up hot gluing it on the inside to make it stick. But it was a pretty tight fit. I mean, I dremeled the hole out a little bigger each time until I could get this thing in with a bit of excess force, and that seemed to work well. Alright, so there's the finished hole. And that looked pretty clean. I didn't destroy the finish. of the box, which was nice. And you know, this was intended to sit on a shelf, probably in this orientation, so the speaker hole is pointing up. And the speaker that I took apart, the powered speaker, had a little speaker cover inside, and so I took that and I put it inside, so you've got something to protect the actual speaker cone. And so that looks kind of cool, I think. So that's all good to go. All right, next, I was going to use a Raspberry Pi, and I wanted it to sit inside the case. And when I got the Pi, it was running really hot, right? So it's a Pi 4B, I think, something like that. It's a little workhorse, but it does run pretty hot. Everybody recommends a fan. I usually don't worry about stressing hardware, but I decided let's go ahead and do this right and put a fan in there. So went to Amazon and looked for a fan. Well, for a few bucks I found a case that came with a fan, a bunch of heat sinks, and a 3-amp power supply. And this was all 16 bucks. I think it was cheaper when I bought it. And it's all nicely self-contained, so this should keep the unit pretty cool. You've got access to all your ports. And the power supply was a plus because I was trying to figure out how to best drive this with enough juice, because the goal is to not only drive the Pi but also the external speaker and a USB 3.0 hard drive powered from the USB port. So these are 3.0 ports over here. So this was one size fits all solution. I got this, and that worked pretty great. All right, next I needed a way to exhaust the heat. I needed airflow for the fan. So again, made a little template out of cardboard, eyeballed where it should be, circled area on the back of the box, and I decided I would go through, as much as I hate to take out Jim Henson's signature, right? It was the most expendable area because it was just some fine print and a barcode mostly. So put the fan right here, right? Drilled out, got the Dremel, went to town on that, same thing, and used that to make a nice hole for the airflow. So you can see my template back here, and there's the hole I came up with, and then of course printed a nice bezel for this to cover up the sharp edges and so on. On the inside, I tried several ideas for mounting this case, and I was just going to extend the screws that hold the case together, but in the end I decided to just take the back panel of the case, put some holes in it, put some screws going through the back of the lunchbox into there with some standoffs, so those were 3D printed also. You can see I started playing around with mounting some switches on the side just to make sure there were no surprises there. So this was how I decided I would mount the Pi, and this holds the case in position with the fan lined up with the airflow entry on the outside. And so that's what that looks like in the end. And I also popped another hole for the power cord and made a little bezel for that. There's the 3 screws holding in the Pi, and there's the hole for the airflow coming through that. So you can see the fan coming through right there, right? That's nicely lined up. It ended up not being that nicely lined up in the end because I mounted the box too high and I couldn't get the lid closed easily with cables plugged into the top of the Pi, but close enough. There's another view of the inside. You can see I hot glued the bezel in place. Those are the standoffs that I printed, and you can see the holes that were there because I moved the whole thing down this time. And the fan's powered by 2 headers that you plug into the GPIO pins on the Pi and just hit 5 volts and ground, and that runs the fan whenever the Pi is powered. And there's a cleaner view of it over there, and you can also see over here another piece of hardware which I made for mounting the hard drive. We'll talk about that in a second. And there's the full Pi in place over here, so ports up there, back cover is on, and exhaust fan in the back. Alright, so this was the mock layout that I did before I started drilling any holes, just kind of trying to get an idea for how this would be oriented inside. I wanted to keep the hard drive over here kind of far away from the speaker with its big magnet. This is before I had taken the speaker out of the box. but still had a lot of space in here. So I envisioned the hard drive sitting over here. But how do you attach it? Now you can hot glue it or zip tie it or any number of things. I wanted it to be easy to switch out because this is just kind of a unboxing drive to use. It's a little 1 terabyte drive, but you might want to throw a bigger one in and so on and so forth. So I wanted to make a holder for the hard drive, something that I could attach to the box with screws, but that would let me put zip ties through and hold the hard drive. So back to Tinkercad and a variety of parts, and basically put these things together, put some holes in the middle there to let zip ties go through. Run some holes through the bottom of it to accept attaching bolts for the case, and then put some holes through this upright post to let us run the zip ties through horizontally. So the idea was you'd have a pair of zip ties going, you'd have a zip tie going in this direction to keep the box from tipping, then you'd have a pair of zip ties going through like this to keep it from tilting. These were holes that I could use to access the mounting hardware, and then I shortened it a little. And these were standoffs that I added at the end. So let's group all of that stuff together. And so there's the finished piece, and basically a pair of bolts go through here, attach this end to the inside of the lunchbox. There's a cylinder I can run a zip tie underneath to attach to the hard drive, and then I can run a pair of zip ties like this to hold the hard drive in the other direction. And then these were standoffs because the lunchbox right along this edge has a little bit of a lip to it, right? And if I try to push this flush, it hits the lip, and when I cinch it down, it tended to tilt. So that was just, these are the kinds of things you can do with a 3D printer. If a part's not quite right, you just go back and you tweak it a little and you reprint it. Lots of rapid prototyping. So with that, here's the part that I made, right? And this worked pretty well to hold the hard drive. So that goes inside. It's mounted up with some bolts, and it sits there like that. There's the speaker and the Raspberry Pi, the power switch to B, and then zip tie running like that, 2 zip ties like that. Those will go around and attach to the drive. And then if you decide you want to put a different drive in, just switch out the drive, put in new zip ties. It's not too big a deal. There's the standoffs holding this piece from being flush on the edge, and a zip drive, hard drive zip tied in, so you can see it like that. And it seems to work. I mean, I wouldn't take this on a roller coaster and swing it over my head while I was trying to upload my dissertation, but for sitting on a bookshelf, this should be perfectly fine. And so there you go. There's the inside of the box with the pieces in place, everything connected except the power supply. So the power supply got fed through the back, hooked into this switch, and then I also put in a second switch as a speaker kill switch. So the wires going to the speaker, I just took the red side and ran that through a switch. So if you want to totally turn off the sound, you just flip that, and you've mechanically cut the volume regardless of any software settings. And so that's nice for late night use and so on. There's my 3D printed standoffs for the speaker. The speaker came with a big cone, but I decided to remove that. One, because it wasn't necessary, and two, because with this thing totally closed up, the Wi-Fi wouldn't get out. I needed more openings in the Faraday cage here to let the signals go in and out of the box. So having this physical space here seems to let signals go through the speaker bezel, and also to some degree the fan port in the back. But everything else was contained, and at first you close the lid and you lose connectivity. So you can see my imperfection in my hole alignment, but it's forgiving because there's distance there to work with. So there's the final wired job, right? There's the speaker switch going up there. There's the power switch coming from the USB-C cable, and I basically just opened up the power switch that came with that cable and removed the switch and just ran the wires into here. And that's the whole inside. So seems to be pretty stable. Everything got hot glued to keep these pieces in place. And there you go. So there's the finished product with the lid closed, sitting on its side. So power, speaker, kill switch, speaker coming out the back, at the top, and power cords coming out of the back, along with the exhaust fan. So there's the power cord, there's the exhaust for the Pi, and there you go. There's my network accessible storage.